Today, we are going to talk about the LeetCode problem 621, task scheduler. This problem is like rated and medium, but I think this problem maybe we need to want to discuss it because I think this problem is not that easy to understand because the pattern is not very common in all the problems. So let's first check the description. So it says this problem has like two inputs. One is like a char array, which is the value represent the task type, and there's like a integer n, which is n means the cooldown time. So it says like it asks us to schedule all those tasks, but there's two things we're trying to achieve. It's like for the same task, for example A, it cannot re-execute if the cooldown time is not reached. Another target is like a goal of us is like we need to make the execution time as short as possible. So let's look at this example. So we have like two types of task, A and B, and we have a cooldown time as 2. So first, we pick one task. Let's say pick A, and it means like in a cooldown time 2, in the next 2 slot, we cannot pick A again. So if we check, we have to pick B. So we pick B here as the second slot, and now we need to choose a third for the third slot. But for A and B, both of them we don't reach the cooldown time, so we cannot find any candidate task for the slot 3. So we have to make it as idle. And again, we go back to this list and choose target for slot fourth slot. So now the A is already reached the cooldown time, so we can put A again. So we continue this process till end of this list. And now we count like how many slots we need in total to process this all those tasks. So in the last example, we just like a random pick task from this array, and but as I said, the second goal of is like make the execution time as short as possible. We have to have some strategy to pick those tasks. So let's evaluate this array. So basically, here I think the original order of all these tasks is not essential because it says that those tasks could be done without the original order. So we have we need to some other strategy to order all those tasks, and at the same time we have to meet the two criteria. One is like the cooldown time. The second one is make the total execution time as short as possible. So this problem, I think the solution is like it's a greedy problem, but it's not that obvious that how to do the greedy because the attribute we choose here to do greedy is like use the frequency of the tasks. So I don't know how could we like come up with this solution if we never know this problem. I think we need some like background knowledge of greedy. You maybe think about like what attribute in these two input we can use to make the greedy algorithms. So here, I think I checked the discussion channel of this problem. There are like some answers which use like math. They trying to calculate the total length. But actually, I don't really recommend those problems because even as a greedy problem, this problem is not that straightforward. If you choose to use math, you have to explain to the interviewer why your equation is correct and is the best answer. So here, let's go for the greedy one. As I said, this problem we will use the frequency as the attribute to do greedy. So because by default, this frequency is not given directly in the input. So I don't think it's very easy. You can come up. We should use the frequency, but as I said before, this kind of problem you have to need to some like background knowledge about this all these algorithms, and maybe you can say let's try greedy on frequency. And second tricky thing is like how can you prove like if you do greedy and frequency, that is most for greedy solution. If we want to prove the optimal, if it's like a most optimal solution for this problem, I think one way is like we could like prove that a smaller problem for a smaller problem the solution is like the optimal one, and we can increment this smaller problem to a bigger size, and we trying to prove like for like a bigger size problem, the solution is still the most optimal one, and we can say since we proved it is optimal one for like all those subproblems, we can conclude that this solution is like optimal one for all the problems. I think that is like one way. So for this, I have some simple example. So let's go over how do we tackle this problem. So first, we need to count the frequency of all those tasks by its type, and we have like a cooldown time as 2. So here we can use the cooldown time as a round, like for each task, we cannot have like more than one execution inside every round. So we can say one thing is like if the cooldown time is 2, actually the round size should be 3. That is cooldown time plus 1. So you can see here, if I have I execute A at the first node, in the next 2 nodes I cannot A again. So I can execute the A and the 4th node. So we can see this from the node 1 to the node 3 as a round. And as I said, the algorithm we do greedy is like we first pick the element. We pick the element has the most frequency in each round, and we process this all this element. One thing we need to be aware is like for the last round, we don't need to count the whole round. We can stop at the execution slot for the last tasks. So here, let's go over the code. Let's see how do we tackle this problem in code. So as I said, there's 2 inputs. One is a char array is indicate all those tasks we need to execute, and n is the cooldown time. So one thing we can say is like if the cooldown time is 0, that means like we can execute those tasks in any order. So we can just return the size of the task queue. If we and after that we create a map. We use this map to count the frequency for each kind of tasks. And we have a max heap. I think this max heap is used for sorting all the frequencies. So here you might notice one thing is like here in this max heap, I don't have the task name, which is in the original chart. That is because like for this problem, the output is only need the total execution time. We don't need to keep the task name. So I just like throw it away after we get all the frequencies. Now, so we feed into all those frequencies into the heap, so they can be like here we start to start our greedy algorithm. So we have like a while loop to process each slot. So as I said before, we defined a new concept as round. I also write down it as row. So the round length is actually the cooldown time plus 1, and we defined a cache list. This is used for to store the task frequencies which we already processed in this round. So after this round, we will feed back them into the max heap again. So why we don't feed them back right after we process it? Because we don't want them to be picked up like in the same round. So here I have like a second inner while loop. So this while loop is like for peak task for this round. So if we like if we have more slot in this round, and our frequency heap is not empty, it still has like more tasks, we can like pop out one task from the heap, and we also like feed that into this slot. So this slot in this round will -1. It means like we already fill out this slot, and in the same time we increment our result is the total time we execute the all the tasks until now. So here, as I said before, if the frequency for this task is still like larger than 0, means like we still have tasks for this one type. We will like add it into our cache, so we can like after this round we can add it back to the heap, so it can be processed in next round. And this if check, this one is like only for the last round. So as I said before, for this last round, we don't need to count the whole round length. We can stop at the this knot which we execute the last tasks. So this if check is for only for that purpose. And at last I have I add the left length for this round. So that means like in this round we have some like idle slot, so we need to add them back to the result for this idle slot, and then we return this result length. So here this is a greedy solution for these problems.